Okay, hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We did some work yesterday evening to add multiple render targets to our software renderer, but although we actually succeeded in doing that pretty quickly, it was not difficult, we actually have not written the code to use any of those multiple render targets. So although our back-end renderer now renders to multiple render targets just fine, you can't do anything with them, and well, let's be honest, how interesting is it really to have multiple render targets you can't do anything with? Not that interesting, I would argue. So let's see if we can do something this time with our render targets. So here we are on day 317. If you are following along at home, you're going to want to open up day 316 source code, because that is source code that I am starting with right now. And I will go ahead and load up for you. And I am loading this for you. Everyone out there, I just want you to know I am loading this for you, our very own Handmade Hero source code. And we are going to run it. And I'm going to show you what I mean when I say that we're not using any render target stuff. We did some weird stuff where we shrunk down. Yeah, we got a lot of stuff that we did that was weird. So we have a kind of weird screen going on right now. But it is actually all correct. This is what we meant to draw. For reasons you will know if you watched previous episodes. And we're running through the software renderer right now. And we're running through the software renderer in debug mode, and we're still getting close to 30 frames a second, so you gotta love computers, because it's in debug mode, so it's much slower than it normally would be, but it's still hanging in there. Good for it. So anyway, what we have to do now is we have to figure out how we are going to get this second render target in play. And so what I want to do is I want to go ahead and move up here. So now you can see I'm standing in between two layers, and we intentionally made these little slats so you could see a little easier. You can see these little green slats that are from the layer above us, and they're kind of coming in, they're getting alphaed in, and then, you know, as I come up, they kind of alpha in more, and I can go back down, right, and I can sort of control how alpha they are by how far up or down this like sort of weird stairwell thing I've made is. So what I want to do now is I want to move all of the things that are on that layer into a separate render target, for starters. And then what it's going to do, because we don't do anything with it, is those things should disappear. So I'm just going to hold the game here, right? And I'm just going to use live code editing to just go edit the code while the game is in that state. And those things are going to disappear, in theory. So let's go ahead and jump over to entity.cpp. We know from the way that we've set things up here, we set up our level indices. We know that basically our last level index, our maximum level index here, is the one that's going to be fogged out. And in fact, not only do we know that, but I believe we're sort of already using that piece of information, I think. Oops, not fog. I meant alpha. My bad. Test alpha. So there we go. So you can see us using the test alpha here of the layer index that we're on. We're doing that only when we're on the maximum level index. So what I can do in this circumstance, if I want to, is I can use the render target system that we have set up to switch which of the clipping rectangles I'm using. So what I can do here is I can say, well, if I'm at the maximum level index, set the render group's current clip rect index to be the whichever one we're using for that top level, right? So we'll do like alpha clip rect, something like that. And then otherwise, in any other case, we'll just set the current clip rect index to, normal floor clip rect, right? So we basically have two different clip rects that we'll create at the beginning, one for the current floor, one for floors that get alphaed out, and one for the normal floor, right? And the normal floor can just use the standard clip rect that we're currently using. And so at the end of all of this too, we could set the clip rect here at the end when we exit, because we're kind of doing a little thing where we, oh, well, it looks like we're already storing it anyway, so that's totally fine. So what I want to do here is say, okay, I know I've got to have two different clip rect index, so I'm going to have my normal floor clip rect index, and that's just going to be because we don't actually need a new one. We can just use the standard one that everyone else uses. We can just say whatever the render group's current clip rect index is fine with us. But then we need an additional clip rect index, and we need that for the alpha floor clip rect. And I don't really actually know how to make one of those because I forgot. I know we've got a push clip rect here, and let's see. So here's my push clip rect call. I'm going to call that. I'm going to use render target 1 since that's the, we don't really have any other need for render targets at the moment. So I've got my render group, and I want to draw to the whole region. I don't actually remember if there's anything in particular here. I guess it's just draw buffer width and draw buffer height. So I guess we can just do draw buffer width, draw buffer height. And now I guess, in theory, I have pushed the clip rect there. These are supposed to be arrow signs. I admit that. So let me fix that for you. There we go. And so now, in theory, yeah, and you can see as I pop back here, the alpha stuff is gone. And so let me just underscore that point to you so that you can see what I'm talking about here. Again, I'll just lean on sort of our live code edit stuff that we built to just make sure that I can show you exactly what's going on. And in fact, I should probably do it in this window, huh? All right. So normal floor clip rect is just using the regular clip rect. Alpha floor clip rect, which is the stuff that's getting alphaed out, right? That's using this other render target. So if I set that render target to 0, now it's rendering to the main render target. You can see it, right? If I set it to 1, now it's rendering to a different render target. You can't see it. So what we need to do now to finish what we were trying to accomplish is we need some way of specifying what should happen to that second render target when we go to resolve all of the stuff that we have. Now, there's a lot of things we could do here, and which ones we do depend entirely on what we are trying to accomplish with our graphics engine. Now, I'm just going to do the most simple, basic thing that we might possibly want to do. I'm just going to write it so that all we really have in there is a hard-coded thing which says, hey, you can push a thing on which says, when you get here, blit, the render target on top of the other render target with an alpha value or something, right? So I'm just going to make exactly the one thing that we need. But I would point out here that, I'm showing sort of this process in the general case more to just give you the awareness that you can have multiple render targets. And so you might decide to do something more fancy if your game could make more use of render targets and doing things with render targets. So for example, one of the things that we would probably do if we were going to do a bunch of fancier stuff with render targets is we would want to go make it so that it was very easy for us to use something that we rendered as a regular sprite, right? That would just be something we would do as a matter of course. I probably won't bother doing that. I don't think I'm going to bother with that because I don't think we need it for anything. But you can see why that would be powerful, because what you'd want to be able to do is say, like, oh, render a bunch of stuff to this render target, and then use that render target as a sprite somewhere else, which could even then make another render target. So you can understand why you would want to make that system more general if you had some things in mind that maybe could leverage that, like if the look of your game could benefit from some of those things. So I'm just going to show one simple case, but keep in mind that, render targets are a very powerful tool, and if you go ahead and pipe them through and do some more architecture work to make it so that render targets and textures can be used interchangeably, that gives you some additional power that I don't anticipate taking any advantage of, but you might, right? So keep that in mind. Okay. So let's see what we need to do here. Here's our situation. I'm going to close this now because we don't need that up, and I'm probably going to have to reload the renderer, which is in the separate piece of code there. So if I go over to render.cpp and I take a look at what happens here with all of our rendering, you can kind of see we have these render targets here, and we're passing those render target arrays to our renderer. And when we go through our sort entry indices like so, we pull out all of these different things that we think need to happen, right? What I'm thinking is we could just make one here that's sort of like another case, which is like render group entry type, render or resolve render target, something like that, or blend render targets. I'm not sure, something like this. I guess what do I want to say? Maybe I'll call it apply render target, or no, let's call it blend render target. And all I guess I'll do here is make it so that you can say a destination render target and a source render target and just smush them together with an alpha value on top of one of the existing ones that's there, right? So that's all I want to do. And so I'm going to call a function here that's called like blend render target or something like that. It's basically going to be, instead of using output target here, although I guess I could just use output target. I suppose that that's actually something I could just do. Where I guess I have like the clip rect. So how do I currently pass clip rects to these things anyway? What do I do there? I'm not actually sure. Surely somewhere we do some kind of clipping, I would think. I mean, we have to. So here's where we do our clip rect, right? So we know what the clip rect is, so I'm going to go ahead and pass that down. So I'm going to pass clip rect, and I'm going to pass two things. I'm going to pass the output target, and then I'm also going to pass like the source target or something like that. And I don't know. I guess we'll just take a full color as well, probably. I feel like we would take like a color to apply to modulate against like the target or something like that. I'm not sure exactly how we're going to want to do this, but I think we probably want a color. You know what I'm saying? We could do something like one color that multiplies the output target and one color that multiplies the source target as well. So I could do like something like this. So it's like, do this rectangle, this color times this target, plus this color times this target, written to the second target, like overwrite this one. That seems like a pretty generic operation that we could do. And so that's what we need to write our software renderer to do. So if we were going to get that out, right, it sort of now implies exactly what the information is that we would need to have coming down here. We basically have a blend render target entry. And that blend render target entry just has to have these things in it, right? It has to have the source color. It needs to have the source target, but it's going to be a source target index, right? So really, we probably want to do loaded bitmap source target equals render targets, and then it's like entry source target index or something like that, right? And then here we know the output target, that's just whatever you're currently drawing to. So all we would do is grab the dest color out of there, right? So I think that's it. That seems reasonable, I guess, to me. Yeah, and I don't know how we want to do those colors. I don't know if we want to pass those colors in RGB or linear, sRGB or linear space. I feel like we're just going to call this dest modulate and source modulate, so it's clear what it is, that they're just multipliers, that they're not going to be adjusted for sRGB or anything else like that. They're just going to be straightforward. I think that's what we probably want to do. Don't quote me on that. We'll see when we get in there, and maybe we'll change it around. I'm not entirely certain. Anyway, internal void. We've got a rectangle 2i. We've got a color. we have a source target and a output target, and then we've got a destination. So something like that. And I feel like, you know, we can probably just use essentially the same code that we were using for our rectangle fill, which I don't really remember whether we actually did an optimized version, but I think we did an optimized version of the rectangle fill. So here it is, right? Here's our draw rectangle. So I believe if I come down here, I should be able to just sort of snoop. Why do we have an if? Oh, okay, it's a like here's the old version kind of a thing. All right. So I'm going to go ahead and grab this, and I'm going to put this down here, like so. So there's our blend render target, and what I'm going to do is I'm going to start. I guess I'll start with just exactly the way we were doing it before, where we've got a reference version that I'll run first and make sure that that works at all, and then we'll go from there, right? Okay, so I believe that this is just our, you know, I can call that rect. It's not really a clip rect at this point. So I should be able to do this exact same thing here, where I can just call, well, I don't even need to call anything because it's already a rectangle 2i. So we can go ahead and get rid of all of this. We don't need any of this color stuff yet at the moment. And so really all we're going to do is do this exact same loop here through all of the code. Let me go ahead and place those. I don't know why they look like that. So what I need to do now is I need to do this operation. This was previously a rectangle fill, right? So we found the row we were starting on. Well, it's actually the row and pixel, like the row and column we're starting on. We would increment it by the pitch every time, and then we just go through and romp in the colors, right? But that's not what we want to do this time around. This time around, we need to do an actual operation to create whatever the pixel is going to be. So we need to do like an unpack and then a pack of the colors and all that good stuff, right? So yeah, so we need to do some work here. We need to do some alpha blending work here, and we need to do essentially the following equation. So we've got our source color is going to have to be something, and our dest color is going to be something. We have to load both of these, right? Then we're going to have to make our result. Our result has to be, you know, our source color plus our dest color. And we have to sort of make that operation work with an alpha value. The alpha value in this case is going to come from the source. The source's alpha is what's going to determine it. So we're basically going to have, you know, an alpha value that comes from the source color's alpha. So we're going to do 1 minus the alpha. This is the standard linear blend we've used over and over again. So we're going to do 1 minus the alpha plus the alpha times the dest color. To do our blend, right? And now that's non-pre-multiplied alpha, but of course it should, in theory, be okay because we're just doing pixel to pixel, so we're not doing any other operations, so in theory that should work and not create any artifacts for us, and it would be a lot harder for us not to do it that way because we would need to pre-multiply all of our colors by their alpha values, which I don't think we're currently doing. Right, like when we write into those buffers, I'd have to think, are we actually doing that or not? You know, I don't know. I'd have to think about that. So when we write in an alpha value, we are taking the colors, I guess. Technically. Well, okay, but the more important part here, I guess, is that it comes from the source color. So obviously that has nothing to do, we didn't pre-multiply the things by that, right? So that's the more important here, the more important part here for sure. So I guess that's a good point. So really we wanted to say the source color comes from modulate. That's actually, I suppose, the more correct thing there, because we're loading it from that. So okay, so that seems a little more plausible to me. Yeah. So if that's going to happen, this is going to be a little bit tricky, actually, now that I think about it. And I suppose we could also not do the source color, desk color thing. I'd have to think about whether maybe I'm overcomplicating that. Like maybe we're just creating too many math ops in here. So I suppose what I could do also is just say maybe all we have is the alpha between these two. So it's literally just a single lerp, you know? So that way we can just load, you know, source color, desk color. These would just be loads. The alpha is just whatever we pass in. So then we do the 1 minus alpha times and plus the alpha for the desk color, and maybe that's better. That seems reasonable. Probably also we want it this way, I would guess, because we're probably saying how much we want to go towards the source target. Of course, if that's the case, we probably want it to look more like this, because if that's the way we would normally write a linear blend, right? We'd say go from the desk to this much of the source. So probably that's a little bit better. All right, so let's take a look at this. Blend render target. So let's say we were going to do that. It would look like this. Entry alpha. And back we go. All right, so when we lift these two fine fellows out of the bitmap, we're going to get U32s basically out of it, right? And we're going to have, like, I'm going to have two of these. I'm going to have a dest row and a source row. They're both going to do exactly the same thing, essentially. It's just the buffer part of things. This is going to be a desk target in both cases, and this is going to be a source target in both cases, right? Then through here, same exact thing happens. We've got the desk row and the source row, and they're going to be updated by the desk target pitch and the source target pitch. And when I am advancing, I need two of those as well. Okay. So in this case, I've got a desk pixel and a source pixel. And so we're going to do source pixel, desk pixel, and we're writing the desk pixel. All right, so that's all we're really doing for loading everything in. It's just now we're going to have to, and in fact, we're pretty much done here. It's just we need to convert from U32 packed color up to a vector, do the math, and then convert back down to packed again, right? And so, you know, that's this stuff right here. Yeah, don't we have some, do we seriously not have like a call to just do an unpack with alpha? We have an unpack 4x8, but it doesn't, I mean with gamma, that's what I meant to say. We do an unpack 4x8, but it doesn't do the gamma. But, well, that's okay, because the gamma is just squaring the numbers, so I suppose I can do that part after the fact. So yeah, so unpack 4x8 is what I need to do here. And then do we have a pack 4x8? is it that we have a unpack 4x8, but we don't have a pack 4x8? It's a little strange. Isn't that a little strange? Maybe I'm missing something. But it seems, I mean, it just seems like we would have written that. Evidently we didn't. Who knows why? Certainly not me. So anyway. That's all we're talking about here. So yeah. So in theory, we should be able to just use that. And happy birthday. Yeah, so like I said, this doesn't actually do alpha properly, I mean gamma properly. So I think we also want to do here a like a square. On the way in, and we want to do a square root on the way out. If we want the gamma to be respected, because those are frame buffer values which have been stored in gamma. U322, that's a lot of bits. 322 bits. Maybe it's for cryptography, who knows. Got a few typos here. Well, not really typos. Non-ported code. That's what it used to read. Let's go ahead and get that cleaned up a little bit there, just a little bit. And see if we're any better. So what are these, S32s? Yeah. All right, so now that's gonna be some real slow, nasty, not very good code that we can SSE in a second. We might even have time to do that tonight. We'll see. Maybe not. But we've got our render group has to be able to actually store the fact that the user wants to do this thing. So I'm going to go ahead and put that in here. Oops. So let's do render group entry type, render entry blend render target. So yeah. If I do that, then I should be able to create one of these that just has the stuff that I just said it had, right? So we've got a struct. It's one of these. It has a source target index. It has a output target, which we know implicitly through the clip direct. It's got an alpha value, and it's got a source target, which we already know. That's what I put right there. So it's really just that. That's it. And that's all we needed. So what is the problem? Something should be preceded by something else. Need a colon. That would help for starters. And render target, that should have looked like that. Okay, so now we're good to go. This won't do anything because no one is ever pushing on that actual call, right? So it's ineffectual. So you can see we still don't see anything happening there. But what I'm going to try anyway, and let's see if we can make this happen, is I'm going to try pushing one of those on. So, you know, we've got sort of this, where is it at here? let's see, perspective and render group, orthographic. So essentially what we need to do is we need to push one of these on, and we need to push one of these on in a way that you know, is not going to get sort of messed with or sorted with anything else. Now, previously we took the clear and we sort of put the clear out in the middle of nowhere, and by sort of putting it into a separate thing, we kind of need that to come back. Because like right now we're not actually clearing our render targets at all, so we got other things we're gonna have to deal with here. But point being, let's start with one thing at a time. Let me actually see what we are doing for that. Yeah, so we don't actually clear anything other than the initial render target. So really we probably need to clear all the render targets, or have the user specify when to clear them. So I think we should probably do to-do Casey put clears back into the list. Just use sort barriers to isolate them. Is probably the right thing to do. So anyway, here we go. I'm going to do this way. I'm going to say target index equals 0. Target index is less than commands max render target index plus target index. So this way I'll just have it so that everyone gets cleared using the initial clear call. Of course, that's not going to get live code loaded because that's not actually in there. But okay, so inside Handmade render group, if I wanted to do a composite operation here, what I'm going to do is say, well, you know, I want to do a standard push call here, right? Like I would like to do effectively like what push bitmap does. Or actually, you know, probably more almost like what push cliprect does, I think. Probably something more like that. Yeah. So I'm gonna grab this guy, and I'm gonna put it down here. Gonna go ahead and say push target blend or something like that. Push blend render target. And I'm going to call this the source render target index. And what I'm going to do here is I'm going to ask for a push buffer push. I'm going to say that I want a sort entry and I want a render entry cliprect. I'm sorry, render entry blend source render target. Assuming I get one of those, I'm going to go ahead and fill it out. And this stuff is all irrelevant. So yeah. So when I push and I ask for the sort entries, if the render target stuff, I don't ever want this to be sorted. I want it to just happen in the stream wherever you say it's going to happen. So I'm going to try something here where I just push 3 sort entries on. And so those 3 sort entries are going to be like 2 sort barriers and just 1 op, you know, this operation basically. So let's see here. How do I push a sort barrier? It's really just that. And so what I should be able to do here is set these up in that way. So let's see. So let's just do sort entry. So push sort entry. How does that happen? How does that happen? Where is that struct? There it is. I wish you to come out to the outer side of things. There we go. So our sort entry 0 and our sort entry 2 are going to look like that, but our sort entry 1 is going to look like the actual offset that we care about, right? This value, basically. So I'm a little confused. As to why this is called header. Why did we call that header? Because is it actually the header? And if it is the header, isn't this wrong? Hold, please, while I think about this. Yeah, so isn't that wrong? When we do a push clip rect, oh, I guess not, because the push clip rect doesn't need the header. So I suppose that's actually okay. But this guy does. So this guy actually does care about that, if that makes sense, because he's a real thing. So I've got this rectangle push happening here. Blend render target. I guess we don't need any of these. This is really blend. So this blend is going to have a source render target index, which we took, and an alpha value, which I forgot to have. But that's it. And the other thing that I'm not sure about is we have to fill out some of the other bits, I think, here. So, I could also, and I probably should, now that I think about it, I should also probably go ahead and take, rather than doing sort of that finicky stuff myself, I suppose I could take this and still just use it and just do a push sort barrier. Instead of trying to be efficient about it, because it's not something that's going to happen very often, I could instead just do, hey, do one of these guys where I do a push render element, of render entry blend render target. Let's see here. Here we go. And rectangle to I, screen area, we don't care about, and sort sprite bound, sort key. These are meaningless because we're not actually going to ever have it sort against anything, so they can just be completely irrelevant, if that makes sense. And then I don't have to do this. So now that I've got my blend, I can do whatever I want. And then I just need to put some code around it that will prevent this from being a problem. So I can push a sort barrier here, push another sort barrier here, and then I know that nothing, like when that was said, it will do the blend at that time and it won't sort against anything else or create problems for anybody, right? So that seems good. All right. So now I should be able to do this blend if I want to. So if I go into entity.cpp, I'm going to do this in 2 steps here. the first step I'm going to do is I'm actually going to re-enable this momentarily so I can see what I'm drawing. So there they are. I did that so that I can go, I want to take that alpha and I want to get rid of it. So this entity transform T color bit, we want that to just be, I guess, all zeros in this case, right? So now it's completely opaque. And what was the actual value there? Okay. So I'm going to make that be that way. And so now we know it's getting drawn properly. And then at the end, we will composite those on top of each other. So then what I'm going to do is push one of these blends, the source target index and the test alpha. And off we should go. Of course, what are we doing here? We actually don't care too much about this, so it's always just maximum level index. We can simplify this a little bit now that we know what we're doing. All right. Oh dear. That didn't go well. It looks like this is, for some reason, are we still compiling in optimized mode? Ah, no wonder we were getting 30 frames a second. That did seem a bit high for unoptimized, but okay. Never mind, I take it back. Now we'll be much, much slower. Okay, so let's see here. It looks like our source target is bogus. I'm not sure why. For some reason, the max render target index is 0. But it definitely saw... Oh! That's actually correct. We aren't using that render target yet. So I'm going to do alpha floor render target equals 1. Alpha floor render target. And then so that is actually a correct crash. No one should have called that. Okay, so now we're doing an incredibly expensive, incredibly slow composite step. I should probably compile in release mode to have any prayer of running this. And as you can see, it's horrifically slow, right? Because we're doing this really expensive, really slow, sloppy stuff for every pixel there, and that's not good for anybody. All right, so if we come up here, let's get to a point where we should be seeing some alpha, like here, for example. And it doesn't look like we're getting any, like, okay, so it kind of looks like whenever we're expecting to see something here, we're not actually seeing anything. So I'm going to step in. Well, of course, it's going to be all optimized, unfortunately, so I don't know that I can see too much, but I want to get a sense of what's happening in our blend code. Whoa. Thank you, welcome tablet. I did not actually want to do that. All right, so that's some fantastic typing there. So we're going to have to fix that, to say the least. So obviously, if the source color is getting squared, I don't even know. I was kind of sleeping here, obviously. I don't know what I was doing exactly. That's supposed to be, both of these are supposed to square themselves, and then this one's supposed to be result. So that was just like cut and paste fun, or copy pasta, as people I've heard call it on the stream. All right. So that should at least be slightly more sane. But we'll see. It still may not be correct. Not seeing anything. Very strange. So we unpack our source color and our desk color from the pixels. We are writing to desk pixel, so you'd think we would see something happening here, but apparently not. So we square these for gamma purposes, so whatever the source color and desk color that we loaded are, we get squared versions of them. We then do, oops. Yeah. We then do alpha blends. I'm going to go ahead and just see, because I would like to find out. What happens if I just hard code the alpha to 50%? So it literally does not matter what the alpha is. It does not produce anything interesting. I'll admit that's a little confusing. Well, I guess it's time to step in. So what I'm going to do here is I'm going to say I would like to break any where the source pixel is not 0. So I'm just going to go ahead and run. I did change the build to debug, didn't I? Yes. So I'm just going to set a breakpoint there, and I want to see what happens when we have a source pixel that's actually got something in it, so I can see what happens. All right, so here's our source color. Here's our desk color. There's our alpha. Oh, those are the same. What? Did we pass the same target? What? Oh. I see what happened. Very clever, Casey. We outsmarted ourselves. This transient clip rect will not restore the old clip rect until after we're done, right? So it's kind of completely useless, actually. Thanks for nothing, transient clip rect. So what we actually want to do here is we actually want to manually set the current clip rect to be the normal clip rect right there. So that was the problem. We were basically blending the render target with itself. Ooh, that is pretty. Can we play the game like that? Wow. I kind of like that. I kind of want to see that running in at full speed. I was not expecting that. I'll be honest. That was not what I was expecting to see. But I kind of want to see that again. Whoa. That is wicked cool. That is really, really cool. All right. Well, you know, cool as it is, it's not correct. So, you know, we're going to have to stop doing it. But let's just take a look at what's going on here with that. So we should be having an even blend here. These are getting squared. What is, oh, is this leaving it is this leaving it in 255 space though? Yeah, so this is leaving it in 255 space. So after I do that unpack, I'm gonna have to oh, there's my, wait, sRGB. Where is sRGB bilinear blend? This is what we actually wanted. Ah. Alright, so basically that was just me not remembering what we had actually written. So that will take care of it for us. I was going to say I've got to take it out of 255 space, but it looks like we already have a thing for that. Yeah, there are downsides to streaming 1 hour a night. You forget the stuff that you've already written pretty quickly. Anyway, so after the unpack, I guess we can just do sRGB to linear. What does that do? So it does the inf 255 and it does the square. So that does everything that we wanted. And linear 1 to sRGB 255 does the exact opposite. Okay, so we did already have the stuff. It just wasn't in this file. Good to know. So really, all we needed to have done was that. Right? And now we're at least running through the old path in a more correct way. Okay. So now we're being operating in theory in the right space, although we're still sparkly, which is weird. So RGB 25 to linear 1 after the unpack. RGB to linear 1. After the unpack of those two, we do the blend. Then we do a linear 1 to sRGB 255, and then we do the pack. Oh, but the pack 4x8 does the multiply. So to make these symmetric, the pack 4x8 should not be doing that. Right? That's actually the correct operation now. Okay. So I think we're getting closer to being correct, but obviously we still have some issues here. I'm kind of loving whatever's happening with some of that drawing, though. That's pretty spiffy. All right. So let's go ahead and put the correct alpha value back in, because we were stuffing the alpha value before, which we don't want to do. Yeah, and then we may be out of time, so we may have to do the rest of the debugging tomorrow, or in the SSE version or whatever, because it looks like it's still drawing somewhat incorrectly, or something is happening odd. I'm not sure what exactly. We'll find out, I suppose. So let's go ahead up here. Why am I not seeing it? Are we not passing the alpha value down? I love how you have to switch that thing to... That's the weirdest thing. Why are we always passing 0? Yeah, it seems like we're not actually passing a valid value there. I think maximum level index is, oh yeah, that's just bogus. What we actually want is the array count. So really, and plus, I guess the other thing too is we don't really need the alpha for anything else. So really, you know, we could just do this. This is what we actually want, right? So that was just a screw up. Okay. So now I think we're good. Let's go ahead and run. Evidently not. And the test alpha from top start Z to top end Z, camera relative ground. I feel like that should be going the right direction, yes? From the top start to the top end, do they go... Yeah. So they go in height order. So it should be as you get higher, you get closer to 1, right? If I'm looking at that correctly. So it should be that at first it should be very low. It should be like an alpha value of 0, right? Yeah. So I'm not 100% sure why we're seeing that. I would like to take a quick look at that. Let's see here. I love how it can't ever tell you any values in release mode. It's like, I have no idea. So how did test alpha get to be 1.0 in this case? I'm very interested to see that. So if I come through here, right, I'm going to loop through here a few times. And when the level index gets to be 5, right, which is how many there should be, or 6. Nope, I guess it's 5. Okay. 1.5 fade top end. So this is a bit strange. So that's saying that the final camera ground Z, so these, why were these set to what they were? Did we have some other weird bug that was happening? Why weren't these when we were using the test alpha before? Why were we seeing stuff fade in like that? We have a bug here that's different. We have some kind of a different bug that's going on. It must have been that before, let me see. This is level index 5. Maximum level index is what? 1? And how are we computing which one to use before? We were using the relative layer minus the minimum level index. So it's whatever the entity Z layer was minus the chunk origin Z. So that should equal 1. I agree with the fact that that should equal 1 on the maximum level index. And that maximum level index, though, you would think would only have been 1 floor height's worth up. Which I guess is what it is. Huh. You know what? No. So it's just been a slow night, and I guess it continues to be a slow night. So that is actually true. The higher the thing is, the less the alpha value should be. So this is yet another case of like, okay, every time we flip the meaning of alpha, we have to switch the way that range is computed. So no need for panic. That was actually the case. And off we go. Of course, I really do need to compile in non-debug mode, but off we go. All right. So now we're still slowly limping along here. Limping. We're going to have to SSE this tomorrow, as you can see. There we go. Now we're actually blending that in correctly. So the current problem just looks to me like that, for whatever reason, is either not clearing or it's not drawing that second layer correctly. So we have some other bug in the render group code that is keeping us from being correct yet. And we want to be correct before we do any of the optimization. So we'll have to take a look at what's going on there for certain. The clear there we go. The clear was only clearing the first one because remember it's the max render target index, not the count. So the clear has to clear both of those, so that could have been part of it as well. If it just wasn't clearing, maybe everything else is actually fine. So let's give that one more shot. Okay. Now it looks like we're good. Okay. All right, so that's all good. We do have one problem here, which is the clear is clearing at 1.0 alpha because it's using that draw rectangle call. So we need to do, like, to do KC, clear also has to actually clear, not blend, because the alpha is wrong. So we have two things we have to do tomorrow. One is we have to make it so that we're actually doing clear, and we should just go make an actual clear. Like not a blend. And the other one is we have to go SSE that. But then I think we're good. Let's go ahead and Q&A. Geiger Lovecraft themed Handmade Hero DLC. Doubtful. Soy Sauce the Kid, are you writing to the second buffer all the time? If so, is it possible to only use when you need it, like during the transitions? So yeah, we could. We are not writing to the second buffer when we don't need it, in the sense that if we just don't output anything to it, it will never get seen. So what we can do if we want to, and this is pretty easy, is in here we can just do like right. So this way we just do only if the alpha is actually enabled do we bother doing any of this stuff. And then you would never actually pay the cost of it, right? So the only thing that we have to do is, and I guess I could also do that right now too. The only thing that we'd have to do is not draw anything that was going to have an alpha there. So like, I guess, I don't know what the easiest way to do this would be. Probably something like, we just want to clip these out in the case where we can't see them. So it probably like, we'd have something called like stop level index. And we'd just do like stop level index equals maximum level index, stop level index. Right. So we default to saying don't draw anything above that layer. And then only in the case, only in the case where we actually know that we're going to draw those things do we bother, right? So then you're not actually paying the cost of that except when you're in transitions, like so. You can see the frame rate take a huge hit there, right? But, ideally, I don't know whether that's really all that great. I mean, at the end of the day, because you figure you don't want your frame rate to be slow at certain times. So, I feel like we should make sure it's just fast enough to always be doing. But it's neither here nor there. Andrew asks, how does the limbless child limp along exactly? Just really powerful ab strength, I think. Inquiry, how many floors can this code support? I envision a tall tower or stairwell peering down 20 or so floors and seeing NPCs acting as normal. Was that your intent? Well, really, it's gated mostly just by the performance, and we're not like I'm never gonna have 20 floors down because you wouldn't be able to see them. The shrinking would be such that you would have to have 20 floors with the exact right shapes, going down them or whatever to make that happen. So we're probably do that. 6, I think, was the number that we were using that we thought looked neat. But yeah, it's supposed to do exactly that. You're supposed to be able to look down there and see like, oh, there's some stuff happening down there, and maybe I need to go down and there and do something because I see something interesting. So that was why we're doing all the extra work to support it in a cool way. I think it's going to be really cool once we put some art in there and clean up all the rough edges because we've got a lot of nice stuff. Canucles, how do you use trace files to debug? Someone trying my game had a crash and sent me a 95 megabyte dump file. Since you once said it's helpful, I don't doubt that, but what do you do with the damn thing? Well, so unfortunately, the answer may not be super useful to you this time around, but hopefully it'll be useful next time around. The answer is you need to, when you do a build that you ship to people, to testers, you need to save the PDB file and the source tree at that time, like off to a separate directory or something. And then what you can do is you can actually load them. I don't know if there's an easy way to load them in here. You can load them in WinDBG, but I think you can load them in here. I'm not always so good with Developer Studio, but I believe you can actually load them in here. Let me put it this way. If you search on the internet, there should be a thing that tells you how to load them in here. You can definitely load them in WinDBG, which is a free debugger that Microsoft ships for debugging crashes and stuff like that. But the idea is if you save the PDB and all of the source code, you can then load the dump into the debugger and see in the code where you crashed. And get some stack information as well, usually, depending on what kind of crash it was. So in theory, anyway, you should be able to do that next time. If you happen to have saved the PDB and the source code from when you built the exe you sent, you could use the one that they sent you. But if not, then not really. All right, not many questions, so I think we can go ahead and wrap it up. All right, thanks everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can play around with it yourself and do some experimenting. We also have a forum site you can go to ask questions, a Patreon page if you want to support the video series. We have a schedule bot that'll tweet the schedule at you if you would like to know when we're going to be live, and an episode guide if you're trying to catch up on old episodes. That's it for today. I will be back here tomorrow, I believe 5 p.m. Pacific Daylight Time. Until then, have fun programming, and I'll see you on the internet. Take it easy, everyone.